Thanks, Dave. Hi, guys. I'm Jason Hill. I'm with Trimble. It's James McCaskill, my lovely assistant for the evening. James will be playing more of a major role in this in about an hour's time when we do some hands-on stuff. As Dave said, yeah, we're from Trimble. It's an American-based company. I'll get into that soon. The CTCT part that you see by our titles is Caterpillar Trimble Control Technologies. So Trimble actually has a joint venture with Caterpillar, the guys that make bulldozers. So what we do is actually apply all the technology from the Trimble side to the heavy machinery and automate the heavy machinery for road and construction type jobs or heavy civil construction. So we'll learn a little bit about that today. So in terms of what we're going to be covering today, I'll give you guys a bit of an overview on Trimble, a little bit about GNSS or GPS, which is really at the core of what Trimble has been about since 1978. More on civil engineering and construction, which is the part that James and I really represent within Trimble. And then we'll get specifically into machine control, machine grade control, which is really what CTCT is about, which is the part of the joint venture that James and I work for. We've got some details there on what the grade control stuff is going to be about. A little bit about predictive analytics, a little bit about security. Some of this is tying into that industrial Internet of Things theme, obviously. Unmanned aircraft systems, augmented reality. And then you guys are going to get to choose some hands-on stuff. We've got a whole bunch of equipment up here with James that you guys are going to get to have a play with and assemble. Dave tells me you've just done a teardown analysis, so you're going to get a chance to put some stuff back together and see how it works. And then I've actually got a Microsoft HoloLens. For those that were here earlier, they might have seen me wearing it. You guys are going to get to have a play with it, experiment with it, see what you think. If you haven't used one before, it's pretty neat. Have a go with some augmented reality. I'm from New Zealand. Go Brendan McCullum, for those that follow the cricket. I speak, Dave doesn't know what that is, American. I speak a little fast, but if you've got questions, please ask, and James will help answer. I'm the marketing guy, he's the engineering guy. Okay, so Trimble started in 1978, so it's been around for a while now. A guy named Charlie Trimble. He used to work for Hewlett-Packard. This is back in the era when GPS was just getting started. Charlie could see the future, and he thought, you know, there's going to be some money in GPS. Hewlett-Packard didn't seem to see it the same as him, so Charlie thought, okay, well, I'll leave and go and do my own thing, and started up Trimble. It was known as Trimble Navigation. These days, we're just Trimble Inc. Certainly more from just being a GPS company, now more into a company that's sort of melding the digital and physical world. So anywhere people are doing work, you'll find Trimble's in that zone. Head office is over in Sunnyvale in California. It's about 8,000 employees now, actually, I should update that, and about 2.65 billion in revenue last year. So it's getting to be a sizable company. Pretty diverse background in terms of how we apply the technologies, right? So we've got a lot of services in the agriculture space, so precision agriculture. So applying GPS technology onto big farms, from traditional stuff like what we can show here today, guidance and steering for those tractors or those implements, through to yield monitoring, so actually measuring chlorophyll on the leaves of plants to know when it's time to harvest. Finding out what parts of the paddock need more water, so moisture management, and then actually selectively controlling the nozzles on a big center pivot irrigator, so we're actually only applying the correct amount of water. Same with fertilizers, herbicide, pesticide. Construction and operations, so we'll get more into that during the slides, because that's really where we come in this construction area, but you can go all the way through from alignment through to maintenance, and I'll get through some of that in more detail soon. Geospatial, this is really the core of Trimble traditionally. This is the traditional GPS for a surveyor. It's really the first major commercial application for Trimble in terms of GPS. Natural resources has been getting more and more into this, especially things like forestry and environmental solutions over the years. Transportation, this has been a massive growth area for Trimble over the last 5-6 years or so, so really getting more into the autonomy, logistics, anything to do with vehicles on the road doing work, efficiency gains that you can drive from the technology. A lot of IIOT in this space specifically. Electric, gas, utilities, water, a lot of, time and frequency. That seems like a pretty boring thing, but as you know, a lot of it all comes down to the timing. GPS or GNSS is pretty much a fantastic truth source for time. In fact, the main, how do you term it? The number one ground station for GPS is actually just down the road at NIST, so just very close to this campus. So that's the cesium atomic clock. That is, I think it's clock number 1 for the GPS system is right here in town. And then obviously we play in the government space, a little bit in the military space as well. So what is GNSS or GPS? I'm not going to assume that everybody knows that. So most of us know the acronym GPS, so Global Positioning System. We use that ubiquitously as the term for it, when what we actually mean is the Global Navigation Satellite System. It's a bit more of a mouthful, so we generally just say GPS. But GPS is just really the US system, right? You've got a bunch of other countries that have got their own satellite systems that are up there for doing navigation. Together, we term that GNSS or Global Navigation Satellite System. So GLONASS is the Russian system, Galileo out of the EU, BEDO for China, QZSS for Japan, and the starter, what's the one from India? IRNSS, yeah, so India's got their own constellation going up. So the modern system is referred to as GNSS, not just GPS. How does it work? So a lot of people think it's angles. It's not. It's actually called trilateration. It's all about timing. So it's measuring the time between the satellites and whatever's receiving it, whether it be your phone or your Garmin in your car, or in our case, like a high-end GNSS receiver from Trimble. I'm actually going to skip over the whiteboard bit and do that at the end if anybody wants to get into it a bit more. But if you want to know more, go and start reading about it on Wiki. There's code phase, which is the main method that most of our consumer level devices use for deriving a position. On top of that, you can do something called carrier phase, which is what Trimble gets into with a high-end receiver, and then there's different correction sources. Some of you might have heard of SBAS, or Space-Based Augmentation Service. That's what the FAA uses for aircraft, so they can rack and stack more planes in the sky. Right, so these are all, you've got base stations that can send out corrections to make your receiver more accurate, a space-based system, virtual reference stations are something else I can explore at the end if anybody wants to know more on that. I'm just getting through this stuff because last year we went a bit long and we want to make time for the hands-on this year. So that's on the right-hand side there, an example of a modern receiver from Trimble. So 440 channels. So that receiver can listen to 440 satellites at the same time, which is pretty impressive because if we go back, we want to, the best accuracy we're going to get is when we get the most number of satellites we're listening to, right? So we want to listen to GPS, GLONASS, Galileo, and trying to listen to as many of those different satellites and those different constellations as we can. And that receiver is capable of getting an accuracy of down to about 3 millimeters, right? Or 30 seconds of an inch. So super tight, very, very small. All right, so in terms of what happens on the civil engineering and construction part of Trimble, which is where we plug in, right? So think about someone who's going to put a new road in somewhere from, say, Longmont to Lyons, I don't know, as an example, or Boulder to Denver, right? So they're going to want to do some sort of feasibility planning. So Trimble has a product called Quantum, takes a lot of geographic information system and geological data into a database. You put the A and B points, basically where you want to start, where you want to finish, and that software basically runs on a mainframe type computer setup. It will then go through and calculate based on the soil, the costs of roads, the costs of tunnels. This is sort of information you put in at the front end. That software will go through and do alignment planning and come back with various options and the various costs associated with getting between points A and point B. So at some point you select which alignment you're going to go ahead and build, get into some more detailed planning in the NovaPoint and TLOS type software. Detailed planning then turns into detailed design, estimating and bidding. So you're getting to the point now where you're putting out tenders for people to come in and actually start doing the work. Someone then's selected to do the work, so you get more detailed planning and scheduling. And then phase 6 is where we come in with our stuff, right? So now the big heavy machinery, the big yellow bits of iron are rolling into the site. And that's when we start moving dirt. And that's where the machine control stuff really makes a difference, right? So we'll get into that in more detail. And then obviously step 7 at the end, some kind of sign off to say you actually built what you said you were going to build and it's where it should be and it's accurate. So yeah, really step 6 is what we'll dig into here.